So today we're starting with 7.1, ratios and proportions, and you're going to use rates and proportions. So a ratio, on your page, you're writing this on the line. Last class had some issues with that. I said definition because I was letting you know that this was the definition of ratio, but it's on the lines. So a ratio is a comparison of a number and a non-zero number using division as an example. So we could write it as 4/7, but there's other ways to write ratios. We can write them as A to B, notice numerator and then denominator, and then it could be A to B with the fraction bar, or we use A colon B. So all of these are ways to represent the exact same thing. So we're going to talk about simplifying ratios. So here you see you have 60 centimeters to 200 centimeters. I'll let you write these down, sorry. I'll give you a second. Okay, so the easiest way for us to do this, the most effectively, is to rewrite this as a fraction. 60 centimeters, remember what comes first is the numerator, and the denominator is going to be what comes second. And then we're going to look to see how we can make this in lowest terms. So smaller numbers, less things that go into it. So what do we have in common between our numerator and our denominator? Both divisible by 2. We can start there. You want to start with yours? I'm okay with that too. We can do both. So how many times does 2 go into 60? How many times does 2 go into 200? 100? Okay. So that's a good place to start. We see now that these numbers are still divisible by something else. What else can we divide by? We can divide by 10. So if we divide by 10, how many times does 10 go into 30? I'm going to switch my color real quick so that way I'm doing it in. So we see that it goes into here. 10 goes into it 3 times. I didn't hit and hit record for this slide. So I'm going to let it record for a second, guys. Here we're talking about now the ratio of lengths of segments. So you see you have one giant segment that's comprised of 2 other smaller segments. And it tells you that DE's distance is proportional to EF. And we know that that ratio is going to be 1 part to 2 parts. And we know the whole length of the whole thing is going to be 45. So if we want to do segment addition, which we did at the beginning of last semester, remember we write it out as the 2 segment parts equals the whole. So that would be something like this, right? DE plus EF equals our whole length. Previously, I made you guys write out DF there, but we know the length of DF. What is it? 45, yep. And then we have a portion here that tells you what your ratio is. Do we know how much of that ratio is there? If 1 part to 2 parts, if we added those together, that would not equal 45. So we don't know what's really there. What do we use when we don't know how many parts are there? A variable. And so the way we're going to do is we're going to use the numbers that are up here, 1 and 2, and they're going to come down here and be our coefficients. So we have 1 and 2, and then we have to represent it by a variable. So we're going to use x. So with that, we now come over here and substitute in. We know that dx, or DE, has a value of 1x. EF has a value of 2x, and we know the whole thing is 45. How many x's do we have? 3x equals 45. We want to find the value of x. We divide by 3. X equals 15. Nice job. So now all this is asking is for you to find those distances. So we know that DE equals x. And what is our value of x? 15, thank you. And we want to know that EF is 2x. So how much does that have to be? 2 times 15 is 30. So we're not looking for a ratio here. We just want to find lengths based on a ratio. So now we're on example 5, and this is talking about perimeter of a rectangle. So I like to draw a picture with this so we can see what our rectangle looks like. And we know that the perimeter of the rectangle is 70 centimeters. How do you write perimeter? How do we find perimeter? you add all the sides. So we have 2 lengths adding 2 widths. So a perimeter equation we can use is perimeter equals 2L plus 2W. This tells you that the ratio is length to width, and length is 3 parts to 2 parts. So 3 parts length, 2 parts width. We're going to do the same thing we did last time. We're going to have to put that into our picture so that we're going to use those same variables, our coefficients, so 3 and 2. And since we don't know what's there, we have to use a variable. So we're going to put those x's with it. So we have 3 parts to 2 parts. And now we want to solve to find our perimeter. How much is my perimeter? 70. What is my length? So here we see that length is associated with 3. So what length do we have over there? 3x. Yep, nice job. Plus 2w, which my w is 2x. So now we get to add those together. We have 2 times 3, which is 6x, plus 2 times 2. Thank you. So then we're going to add 6x plus 4x, which gives me 10x. What is my value of x? 7. How'd you get that? 70 divided by 10. And you see that she is correct. X equals 7. But that's not what the question is looking for. It's looking for your length and your width. We know that length was 3x and width was 2x. What is 3 times 7? Say it again. 21. And then down here we have width of 2 times 7, which is 14. Nice job, guys. So here you see you have 2 ratios being compared to each other. You have A to B equals C to D. And we have the first and, or no, let's try it again. The means are considered to be the second and third terms. So the means in this would be the B and the C. And the extremes would be A and D. So when they're measuring or counting these, I wrote B twice, sorry. D. We have 1, 2, 3, 4 is what they're referencing. And we can find this by using the cross product property. So we're able to use cross multiplications. And it says products, time multiplication, product of extremes equals product of means. I did draw this over here. I don't know if you guys actually want it, but I'm going to show you what they're talking about when they talk about means and extremes. Is when it's written as in the ratio form with the colon. You see the extremes are the outer 2 number. And then we know that our means are in the middle. So just so you can see it, and then we're able to solve by using cross multiplication. Last 2 examples, we want to solve for our variable. So what we're going to have to do is that cross multiplication. We end up with our 3 times 8. And we set it equal to our other half, x times 6, 6x. What is 3 times 8? 24. Nice job. Equals 6x. Want to get x by itself? I divide by? 6. What does x equal? 4. Nice job. So we get x equals 4. After that, this second one is just a little bit more complicated in the fact that you need to use parentheses. Other than that, you're fine. So we have, once again, cross multiplication. 2 times w minus 2. So 2 times parentheses w minus 2 equals 8 times 7. You have, well, I'll go this way. What's 8 times 7? 56. So we end up with 56. At this moment, there are 2 ways to solve this problem. Last class, we solved them both ways. Which way would you like to see first? Distribution or just division? Sounds good to me. So if we're going to distribute, we have 2 times w, which gives me 2w. 2 times negative 2, which gives me negative 4, equals 56. And then now we're just going through the same steps to try to get our w by itself. So what's the first thing that I have to undo? Add 4. That was very quick. Nice job, guys. Add 4. We end up with 2w equals 60. What's my last step? Divide by 2. W equals 30. Okay, our other option, you don't have to work this out, but I wanted to show you it just in case. If you would have had the 2w minus 2 and you did not want to do the distribution, you could divide over by 2 at the beginning. You end up with w minus 2 equals 28. Add 2 to both sides. and you'd have W equals 30. So it works out either way. It's just whichever one you prefer.